Go ahead and talk about our previous unit of no, I know what you're probably thinking. This lady lost her mind. I was supposed to film this a while ago during Halloween, but I just got really busy with my personal life. It's okay. Life is great. Don't take it seriously and have fun. Anyways, what even is electrical currents? Like, what are they? So, literally, what is an electrical current? So, think about it. Whenever you have an electronic device, how does it even work? If you take apart a phone, you know it has a battery. You know it has all those little green chips. You have all those electronic pieces. Sometimes you might even see wires. If you think about a computer, you know for sure it has a motherboard. You know for sure it has to have working buttons. It has to have everything connected. Now that we have fancy technology, sometimes you may even have things that are Bluetooth connected. But how is that going to work if not all the parts are connected? So think about it. What is a circuit? A complete functioning electrical circuit is a system where electricity is being transferred to different parts of that system. So let's go ahead and start off with the big picture. Say that you were having a science experiment in class, right? And then you have to go ahead and connect the parts. First, you gotta have your battery. How can I have a electrical circuit without even having a battery? My battery is my power source, my power cell. I have to have it in order for it to work. Then I'm gonna have my wires. I can't have my transfer of energy from my last unit. Can't change any forms of energy if I don't have my wires transferring the electrical currents to the rest of the system. So I have my battery, I have my wires. Then I'm going to go ahead and connect both ends of my battery. If I don't have a positive or a negative, I can't have a functioning circuit. It has to cycle through in order for it to work. If I have a light bulb connected, I need to make sure both parts are connected. I need to make sure that both ends of the wires are connected to both ends of the battery. I can add a fan or I can add a buzzer. Sometimes I might even add even more light bulbs. You just have to make sure that no matter how many parts you have, they are all connected. Now, I know what you're probably thinking. That's really simple. We learned about this. But what happens if I don't have all the parts of my system? Here's the thing. Say that I got rid of my battery. There goes my power cell. I can't do anything without a functioning battery. Without my battery, I have no way for my electrical energy to transfer at all. Goodbye. Bye, Felicia. It's not gonna work. You have to make sure that you have both parts of your electrical. That was a bug. Ew. You have to make sure that you have both parts. Every single part. You have to have every single part of a functioning electrical circuit system for it to work. Let's talk about two main types of circuits. We have a closed circuit and then a open circuit. A closed circuit means that not all of the parts are there. Either it's not connected or it's put in incorrectly. A closed circuit. Ooh, did I say open circuit? That was supposed to be closed circuit. I'll try to figure it out whenever I'm editing. A closed circuit means that all the parts are in. They're all put in correctly. They're all in the right order. They also are all connected where each end is cycling throughout. Remember, if not all the parts are put in correctly, my electrical conductivity, my electrical current cannot pass through the the system to where it cycles around. We have to remember that. Now, if I have an open switch and then I close it, then I have a closed circuit. But if any part is not connected, if I have something that is blocking its path, it is a open circuit. let's go ahead and model an electrical circuit. So first, of course, I need my power cell or power source, and that is going to be my battery. So I'm going to connect it right here. So I know that for all my electrical circuits, I need a wire. So I'm going to go ahead and use my yarn as an example of how it needs to be connected. Now, my yarn here is demonstrating my electrical wire, so it's going to be my electrical energy that's passing through. Then I need to make sure that I have a functioning part. So I'm going to grab my switch. Now, I'm going to show you what it looks like when I have an open switch. So this is my switch. I'm putting it right here. And I'm going to attach my wire. So I have an open switch. I'm going to go ahead and then connect my wires. And I'm going to have my light bulb. So here is my light bulb. I'm going to put it right here. Now, what you can already notice is that my switch is open. That means whenever the electricity is flowing through, it's immediately being cut off or blocked off because it can't go to the next part, which is my light bulb. So if I have my wire, I have to make sure that it is able to, let me try to tie it like that it's able to connect. So here's my light bulb. You are already going to know that it's not going to turn on. Now, I'm going to go ahead and connect another part, and this is going to be my buzzer. Now, if I have an open switch, and I see that my light bulb is not turning on, and then I have a buzzer, you better believe your buzzer isn't even going to make a noise. If I don't have any electrical currents passing through to my buzzer, I'm not going to have it work at all. I'm going to go ahead and cut this off, and let's just leave it like that. So if I have parts of my circuit, but they're not all connected together, I see that I have an open switch. Not both parts of my circuit is put in correctly. My wires aren't connected right. I have an open circuit. An open circuit means that not all the parts are connected correctly, something is not working right, or it also tells me that my switch is going to be open. So let's go ahead and make some changes. Say that I go ahead and do close my switch. Here's my switch. I now have a closed switch. I'm going to connect it to my wires. Whew. Now, if I notice that it's going to be a closed switch, I'm going to go ahead and flip my light bulb on. Now, if I want my light to stay on, I have to make sure that all the wires are cycling back. So, I'm going to get another piece of string, and I'm going to make sure that I have all parts of my circuit together. So originally, whenever my circuit had a switch that was not closed, my switch was open, it would be called an open circuit. But since I have all of my parts connected, that actually means that I have a closed circuit. I hope this helps you understand to identify that all of the parts of the circuit has to be connected in order for it to work. My model does not show how both parts are connected, but you're going to see it here in a moment when you get to see my classroom example. I know what you're probably thinking. We already talked about the electrical circuits. That makes sense. So what do I need to do now in order to understand the transfer of energy? Let's go ahead and talk about that. Now, we talked in our previous video about chemical, electrical, mechanical, light, thermal, and sound. So, I need to identify the types of energy that I have here. First, I already know that my battery has chemical energy. So, boop, there it is, chemical energy. Then I have electrical energies here going through the wire. And here I have my light bulb. So my light bulb, we already know, is going to have light energy. So let's say that here I have my buzzer. I notice that my buzzer is making noise, it's vibrating. Of course, that is going to be sound energy. But that's still not all of the connections. If I had my switch open and then I have to go ahead and close it, I am moving it over. I'm closing it down. I'm pushing it down. So that means I also technically have mechanical energy in order to make sure that I have my switch closed. Now, here, let's say that I also have a fan. I'm going to add a motor to my circuit. So here's my motor. Now, my motor is moving. It's propelling. So I actually have not only mechanical energy here in my switch, I also am going to have mechanical energy above here. So if I had to go in order of how it works, first I would have chemical energy for my battery. I have electrical energy flowing all the way down. Here I would have mechanical energy. I go back to electrical energy. I have light energy because of my light bulb. Then I go back to electrical energy. Sound energy. I go back to electrical energy. Mechanical energy. Then I finally end with electrical energy, and it goes all over again in a giant cycle. Remember, whenever we talk about our electrical circuits, it's not just talking about electrical energy, it's also talking about the other energy forms. That's why it was very important for us to understand all 6 forms. Okay, bye! Let's look at an example of a circuit. Right here, I have an open circuit. We see the power cell, which is our battery, that is connected to all the wires and our light bulb. However, right there, we demonstrate that we have an open switch. So if I have an open switch, it's not going to work at all. The electricity flow is only going to the circuit, and it's stopping there where the rest of it isn't connected. So you can't have the electrical connectivity pass through. However, if I then close my switch, my light starts to turn on. So then my energy flow is finally going through all the parts of the circuit and going back to the battery. Let's look at another example. So here, I was supposed to have a closed circuit, but my switch fell off. However, if we're looking at our different parts, first we have our power cell, which is our battery. It has chemical energy. Then we have electrical energy that's flowing through each of the wires. I have a buzzer here that demonstrates sound energy. I have my light bulb that represents light energy. I was supposed to have a closed switch, but it's broken. And then I have the rest of my wires coming back up, and the electrical energy is going back around. So this is what we mean when we talk about the transfer of energy in a circuit. We have to know that the energy is flowing if all of the wires and parts are connected. So if you have an open switch, it's not going to work. Once you do have an open switch, your light bulb is going to turn on.